Okay, welcome back. We're adding a toString to our guy here, so I'm going to do a Control-C, go down to this guy, and give me a Control-V. And of course, I got some red ones in here. Before I fix the red ones, though, I want to do what it is we're trying to do here, which is to take the information we had and add an extra thing onto it, like comma type equals non-exempt. Now this isn't a variable or anything. I'm just adding the text non-exempt onto the end. Okay, so this I can't use the private field variables, but I can use this dot get first name, and then I can go over here and do this dot get last name, and over here and change that guy. This dot get department. Now this works, okay? This is actually going to work just fine. However, you might be able to look at this for a minute and figure out there's actually an easier way of doing this, okay? Because I'm lazy. I like using the supers as much as humanly practical because they do all the work for me. So I'm going to start like this. String answer is equal to the super version of toString, because all I want to do is take the super version of toString and add something to it. Well, isn't that what we're talking about? Type equals non-exempt. Right? Okay, let's go see if this thing worked. So I'm going to go back over here, and somewhere in here I'm going to have to add a display append. Let's just do imp1 toString like this, and I'm going to copy and paste because I don't like typing down to here right before they do the pay, changing that to imp2. Okay, let's see if this thing works. And ta-da! Okay, I get first name Bob, last name department sales, and down here I get Jane Doe, department engineering, type, oh, I forgot to put the comma in there, type non-exempt. Okay, do you see why this is better? I don't like making a lot of typing, so I want to use the super as much as practical. If you can figure out my motive here, it actually makes a little bit of sense. Okay, cool. So I could keep going. What about the pay parameters? Is there anything different in here? Do I need to do anything different? No. Well, if I don't need to do anything different, I'm going to leave it alone. So the only time I overrid something was when I wanted to make some changes. If I didn't want to make any changes, I didn't override it at all. So this guy has an overridden toString because I wanted to make a tiny little change. This I wanted to do an override because there's lots of changes. By the way, there was no real opportunity to use a super here because it would have made the math very complicated. You know, to start with the number of hours based upon that, and then you have to go in and subtract out the, you know, kind of a pain. So in this particular case, I didn't use the super. So I used the super here, I used the super here, and I used the super there. And this is the only one that had anything complicated in it. Okay, is this making sense? Okay, good. So, one more time. So I'm using the super keyword to talk to the super class to be able to invoke its methods. That makes sense. And we've done this before. I mean, we've done this when we have, like up here where we have like onCreate and we have super onCreate. We've done that before, right? Actually, it's not much new. Okay, moving on to polymorphism on page 282. So this is not really a complex topic. It's just one of those cool little things about how inheritance works. Because if I write a payroll app that says, okay, it's time to pay everyone, I don't really have to know whether or not you get paid overtime or not. I just say, calculate pay. And the machine's going to look at it and go, ooh, I see that you're this type of employee, so I'm going to use that calculate pay. Oh, I see you're this type of employee, I'm going to use that calculate pay. I don't have to do that at all. The machine can figure it out on its own. Okay, that kind of making sense? All right. So I'm going to do this, and I'm going to use a thing that we haven't really done before. It's a well, okay, it's an array list. Okay, so cool, an array list. I'm going to do array list employee, which means the only thing this thing can take is employees. It can't take kumquats or anything else. Is equal to new array list of employees. Okay, cool. So I'm going to add an employee. So this first one is just going to be imp1, which shouldn't be complicated at all because imp1 is an instance of the employee class. No problems. And then I'm going to say imp list add imp2. Now, it does not complain. Why? This is not an array list of employee non-exempts. It's just an array list of employees. Ooh. So the array and the array list have, I'm going to go ahead and say this out loud, but it's kind of corny. It supports polymorphism by default, which means array list of employee type will take an employee or anything that is derived from employee. So since employee non-exempt inherits from employee, it's okay. Now I'm going to use an enhanced for loop. Don't worry about the mechanics because we haven't got to the array list part of the book yet. So don't get bogged down in the details here. So I'm going to say employee imp in this imp list. And then I'm just going to calculate their pay. Actually, I'm just going to steal this because I'm lazy. Okay, so I'm just going to say, why don't I just change it to pay rather than... Okay, so you should ask yourself, is it going to give the correct answer? You bet your yes, it's going to give the correct answer. Pay of 420 and a pay of 430. Now, how did it do that? Well, that's the essence of polymorphism. Essentially, if this was my payroll application, I mean, clearly it would be a little bit more complicated than that, but just bear with me. If this was my payroll application, I could add another employee type. I could have a dozen employee types and not have to change this code at all. Do you see the brilliance of this? The brilliance of this is encapsulation plus inheritance means I can add another employee type and it will have no side effects to my payroll application. Isn't that the essence of encapsulation? That I write a payroll app that spits out the pay and I don't have to know how it works behind the scenes. I'm assuming that you do, and so you've written it to the very specified, but when it comes time for me to use it, I use it in the general sense. Whew. Okay. That was a little weird, but I think you guys have got this thing. Okay. So, the generic employee class is just fine, and when the machine asks for it, it says, look, I know you told me you were an employee, but before I run CalcPay, I'm going to go check to see if there's a better version of CalcPay for you. In the first time, there was not a better CalcPay, the first roll through. But the second time, it goes, whoa, wait a minute. There's a better version of CalcPay. There's one for this non-exempt person. I'm going to use that one instead. And so that's the way that worked. Okay, moving on. An abstract class on page 283. The way when you're doing inheritance, what you really ought to be doing is you're starting with something, and then you want to be able to add to it, okay? That's kind of sort of the way it works. If you find yourself in a position where you have to start removing things, that gets ugly. So, for example, let's say we had another employee type called commission. So it was employee commission. And they only get paid like a percentage of their sales. So it doesn't matter how many hours they work. And they don't even have a pay rate. So if I was to inherit from employee, I would have to basically try to erase or ignore, the hours and the pay fields. That's a little ugly. And so if you find yourself in a situation where you're having to remove features, then you're probably not doing inheritance right. You probably ought to start over with a different employee class. So a minimal employee class that only has the bare bones things to it so that you can add to it but never subtract from it. And typically that would be an abstract class. An abstract class would be something that would just be bare bones basic. For example, if not everyone has hours, well then don't include hours. If not everyone has pay rate, then don't include that. But everyone does have a first name and a last name and an employee ID and a department and a bunch of other fields. Okay, you following? So an abstract class is never intended to be instantiated. Ooh, I'm gonna build one just to show what I'm talking about. So I'm gonna go here and build me a new Java class, and I'm gonna call it employee base. Cool. And I'm gonna make this public abstract class. Cool. What is it complaining about? Oh, it took out my word class. Okay, I'm not going to do anything else to it because that's not really what we're after. What I'm going to do is I'm going to try to create an instance of this guy and just see what it does, okay? So if I said employee base E is equal to new employee base. Yeah, first of all, it's trying to save me from my my insanity here. Okay, and so what do you think that the error message says? It says employee base is abstract and cannot be instantiated. That's that horrible term, instantiation. Okay, so that kind of makes sense. So if you find yourself in a scenario where you have to remove stuff, then stop, make an abstract class. It's clearly not intended to be have things built from it. It's just framework, okay? That's all. It's just a framework. On page 285, they talk about a different type of framework, a thing called an interface. Now, we're not going to build an interface in our class, but we could. An interface is sort of more like, it's even more lightweight than an abstract class. It has the bare bones, but doesn't even have any code to it. In other words, it just has the name of the method, but no code in there. Like it has the the get name and the set name and the get hours and the set hours, but no code. It's just completely blank. Okay, so it's a very, very, very lightweight thing. Now we don't build those things in our class, but we use them in an upcoming class. Okay, so interface works like a contract. When you go up here and say that I want to use an interface, instead of using the word extends, use a word called implements. So my class implements an interface, and then when I do that, as soon as I say it implements it, it's going to say, you have signed up for a contract. That means you must have these methods. And you go, oh, okay. And there's even a button that says, hey, would you like me to implement those buttons for you? And you go, sure, go right ahead. You hit the button and poof, it'll write some code for you, which is kind of cool. And we'll be doing that in an upcoming video. So an interface is like a contract. Once you say I implement an interface, then you're kind of stuck. You have to follow what it says. Whatever methods it says you need, you're going to have to do those. All right. Now I'm going to skip ahead a bit and go talk about enumerations in just a minute on page 690. It's actually on chapter 29. But as usual, we're coming up on a 15-minute mark.